Hi guys, this is the third video using the same worksheet, the one that says I love baby stoic. All right, so I went ahead and did the wrote the equation, but I'm going to go ahead and erase it and we'll do it together. All right, so aluminum sulfide, let's go ahead and do that here. Aluminum has a charge of +3, sulfur has a charge of -2. You swap the charges and you get aluminum 2 and S3. So you're going to go ahead and put that here, Al2 and S3. Next thing it says is potassium chloride. Potassium has a charge of +1, chlorine has a charge of -1. You're going to swap these charges and you're just going to get KCl. Then it says aluminum chloride. Same thing, aluminum has a charge of +3, chlorine -1. You swap the charges and you get Al1Cl3. So we're just going to put LCl3. All right, and then next thing is potassium sulfide. So potassium has a charge of +1, sulfide has a charge of 2, and then we need to balance this. All right, so you're going to balance it. Look at how many aluminums we have, 2, and how many we have here, 1. So my suggestion is let's go ahead and put a 2 here. That makes our chlorine 6. We have 1 here, so we're going to put 6 here. And now I'm going to go ahead and put 1 here. My sulfur is 3 here, 1 here, so I'm going to go ahead and put 3 here. And that makes my potassium 6. My potassium is 6 here, so we're good. Now let's go ahead with the problem. It says how many moles of potassium chloride are needed to produce 80 grams of potassium sulfide? So notice it's not the same chemical. We're doing the same thing. We're going from A, in this case grams of A, to moles of B. And we're going to follow the path on our mole map. Go ahead and write down 80 grams K2S over here. Extend that and let's go to our mole map and see what we need to do to follow the path from grams of A to moles of B. Oops. All right, grams of A right here, guys. Can you see it? It's responding. There we go. All right, grams of A to moles of B. We're going to follow this path. We're going this way. We're going to follow this arrow. And then we're going to stop here, right? That's all we need. So when we're going down this pathway, it says to do 1 mole over molar mass in grams. So let's go back. 1 mole of A, right? That's where we started, okay? And then molar mass of potassium sulfide. So those who still don't know how to do molar mass, here's another learning opportunity for you. Let's go ahead and do that. Potassium, how many potassium we have in K2? We have 2, so we're going to put 2, and sulfur 1. So get the potassium's average atomic mass from the periodic table. Potassium is 13.1. And it's, of course, grams per mole. And then sulfur is 32.07. It's grams per mole. So we're going to multiply and add them up. And you should get 110.27. So whatever numbers you get here, you add those up and you should get 110.27 grams. All right, so you're going to put that here. K2S. All right, and then we need to go back and see what we need to do. Now it says to go here. We did this. Now we're going to mole B. So we're going to do mole B over mole A. And we are using our equation for this mole ratio. Okay, this is your mole ratio. So mole B is potassium chloride. And then mole B is right here, 6. So we're going to put 6 mole KCl over A, which is your potassium sulfide. And that is right here. You're going to use this 3 mole potassium sulfide. And then put it in your calculator just as you see it. 80 times 1. You don't have to do it 1, but if you want to, you can. So 80 times 1 divided by 110.27 times 6 divided by 3, and you should get 1.45 mole potassium chloride. All right, guys, I want to show you that, you're going to end up canceling these grams of potassium and then mole of this, and you're left with what you need, moles of potassium chloride, which is your answer.